So today I'm talking about generative AI and natural or perhaps unnatural history reimagining. And it's kind of just a broad overview of really how things have changed since the talk that I gave last year, which was in April 2023. And I wanted to just dedicate this to my father and my sister, who sadly passed away last year. My father was a landscape painter and my sister an archaeologist. And what you see in front of you there are the Mandu beads that she discovered during her PhD research in the 1990s. And these are 30,000 year plus old beads that were discovered in a cave on the coast of Western Australia. So this is for them. Oh, and you can go and find out about them. I put their Wikipedia pages down at the bottom if you're interested. So what we'll cover today is a bit about me. I'll briefly recap what I was doing in 2023, and then talk about a project that I undertook between 2022, 2023 called Playable Earth. And then, as you're probably all aware, the huge proliferation of AI being everywhere in all sorts of areas now of computational work and research, and then some introduction to the generative AI toolset, all the stuff that I've been working with anyway, and then some examples of how that's impacted the work. So my background, I have a fine arts background and in media arts, and a couple of PhDs, one of them in semiotics and art history, and another in not computational semiotics, computational geophysics. That's a bit of a typo there, data visualization. And I've been working with stereoscopy and, early VR platforms since the mid-90s, and that had a long working relationship with Paul Burke, who you probably know, and of course, Sarah. And I'm currently deinstitutionalized as a independent researcher and creator. And I've spent 3 seasons in Antarctica. And like most people who go to Antarctica, I wish there had been more, but I'm unlikely to get to return unless I go on a cruise ship or get some amazing scholarship or something like that. This is a timeline of visualization research that I've undertaken, stretching back. Shows how ancient I am now, back to the year 2000. This is when I first started working with Paul Burke, and we were working with Frank Hurley stereoscopic images, gradually moving through sort of dome systems and iPhones and photogrammetry and all this kind of stuff. And it broadly mirrors what's occurring in what's technologically emergent over time. So we can look at, early periods, full dome, 360 surround displays, then the emergence of game engines, then photogrammetry becoming good, VR becoming okay around 2016, and then machine learning becoming kind of usable for someone like me, who's not explicitly a machine learning researcher, around 2017, and then moving on to the future. I'll have to update this to include it only goes up to 2023. So next slide, let's see. So I've got a couple of websites that you can go and visit. There is my petermorse.com.au website, which is R&D, lots of whimsy and experiments and writing and failures and things like that, a kind of bloggy sort of content. So that's a big dump of lots and lots of stuff. And then I have portfolio website, petermorse.net, and that has some of the full dome works that I did with Sarah, such as the traveling Kunkaran Kalpa, which I hope you've seen on one of your dome installations, and also Hemispheres of the Mind, which I did with Sarah and EPFL and Cyril Favreau from the Blue Brain initiative. And so a whole lot of stuff there as well. And it's just it's got rid of all the other experimental junk that's on my .com.au website, so it's easier to navigate. Now, in 2022 and through 2023, it was really very late 2022, mostly 2023. I had a 6-month sort of scholarship or fellowship through an organization called ANAT, the Australian Network for Art and Technology, which is Australia's sort of premier arts and technology organization. There are two, really. There's ANAT and Experimenter. They sort of complement each other. And I was fortunate to be able to work with Professor Chris Fluke at the Swinburne Centre for Astrophysics and Supercomputing, where he was their chair of what was known as the SmartSat Cooperative. And we developed plans to look at how we can work with visualization of multispectral and hyperspectral satellite data and interface that with game engines. And as we started working on this research, this is when AI really sort of exploded and took off. So specifically, ChatGPT became available then. And it became really apparent to me that this was going to be super useful in terms of developing techniques for visualization, such as, because I found it very helpful as a coding assistant, particularly if you're working with satellite data. There are lots of very sort of obscure and highly specific image processing packages for Python that you can either spend forever or years learning about, or you can do it quickly with an assistant like ChatGPT or an AI assistant. And to me, this was very liberating and illuminating. And there's a whole blog there which covers the sort of issues that we explored during that research together. Now, just today, what was of great interest to me, it's come out it was in Nature this morning. I was reading it. It's the Artificial Intelligence Index Report 2024. And this is a very striking sort of graph on the side here. So it's a very reputable sort of source. And and on the left-hand side are the main points that they're making, that AI beats humans on some tasks, but not on all, thank God. It's mainly driven by industry as opposed to research, probably because, I mean, university sort of research or academia, probably because of the very high level of compute that's required. Frontier models are very expensive, et cetera, et cetera. So that's well worth going to go and reading that report. I put a link down there at the bottom. And of course, the very striking thing here is what's occurring with the really this very, very rapid advancement in the capabilities against the human baseline here, against a whole series of different tasks. And this, I'm not going to get into discussions about AGI or P-Doom or anything like that, but it's clear that these models are becoming very capable. And that from a researcher's point of view, one needs to be crucially aware of them and think of them, I guess, as a human in the loop kind of agent or assistant or something like that, that we can start deploying for looking at cultural heritage and visualization. Now, when I was doing the 2023 research, I sort of developed a kind of workflow of how I was thinking about how the different bits and pieces would work together. So I was looking at using thread servers, which are essentially a specialized type of server for serving up large geophysical data sets or geological data and so on. It's really agnostic as to what the sort of data is. But typically it's used for cataloging things like net CDF data sets or satellite data or seismic array data and so on. HDF5 multispectral satellite data. You can put in photographic data resources, 3D resources, and other sorts of things like photogrammetry, and NERFs could be held in a repository like this. And then the idea was that then you'd run through some sort of compute with this, talking to it with Python or C++ or machine learning, AI, LLMs, and so on. And I became very interested in the Omniverse platform through NVIDIA and how that interfaced with then at the time Unreal Engine 5.2, sorry, which has these various characteristics. So, blueprints, visual programming environment, and a great interface with Python, which ChatGPT became very handy at helping me work through how to program for that. And of course, an intersection with 3D modeling input of some sort using a Houdini engine. And these are all systems that we used for a variety of projects with the Playable Earth, and also another project that I'd worked on in 2023 of virtual Macquarie Island, and I'll show you a bit of that later. And then this was all to pipe into visualization interaction XR devices, essentially. So I'm thinking large screens, head-mounted displays, and mobile platforms. And then, boom, with AI really taking off. I have completely changed my perspective on this, and that it's basically AI infects everything. There's AI in the database end, there's AI all through the computation or machine learning, whatever you want to call it, LLMs. They can really affect the whole pipeline that one would perhaps have traditionally thought of. And that requires quite a bit of rethinking about how to set up, I think, data management and visualization systems. And of particular interest underpinning all of this is going to be this emergence of AI agents, which are going to be intelligent systems that will collaborate with you, and presumably you will task them with things to do and they will go and do that for you. So there's a very different sort of emergent compute paradigm that's coming about. It's a really significant shift, I think, and so it takes some sort of thinking through about how that's going to change in the next few years. So we were working with Unreal Engine 5.2 to 5.3. This is the Playable Earth project. And what we ended up doing for that was basically looking at how we can get some hyperspectral satellite data, map it onto an Earth model using cesium, do some sort of computational processing on that, and interestingly interface it with, this was very powerful, emergent powerful thing in Unreal Engine 5.2 was the procedural content generation graphs that you can have there. And we've got a little example of a cesium mesh PCG here. So we've essentially got a surface sampler doing sort of world ray hits onto the surface of terrain, and then putting a whole series of cubes over the terrain. And then this is matching up or being colorized in concert with the various values or spectral ranges that we're getting from hyperspectral satellite data, which is geolocated and mapped on the surface of the environment. The thing about hyperspectral satellite data is that it enables you to do certain analyses of what's occurring in a landscape. So it could be used, for instance, for archaeological surveys. There are lots of emergent examples of that, but it can also be used for looking at canopy cover or looking at soil conditions or carbon sequestration and so on. The difference between multispectral and hyperspectral satellite data is that in multispectral data, you might have dozens of channels of information, but in hyperspectral data, you have thousands of channels of information. So you've got this very, very large parametric space that you can explore with particular objectives in mind. And we were interested in looking at how can we take that out of a standard GIS sort of software interface and putting it, sorry, alarm going off there, and put it into a sort of more gamified, game-like context, and then stream that to an AR sort of handheld device of some sort. So the idea was that I'd be able to hold up my hand. I'd be somewhere in a landscape. I would be able to hold up my hand, my mobile phone, and look at the landscape and have it sort of geolocated and cross-matched with the cesium representation with the hyperspectral satellite data plotted basically in front of me in an augmented reality way. And then I'd be able to query and look at that data. And this is as far as we got, because we, of course, ran out of funding eventually. But it was a very interesting exercise to learn about how to set up workflows for that. It enabled me learning PCG as well, to basically put Hobart, where I was living at the time, on fire, and run some sort of fire simulations through it, which was kind of apocalyptic way of visualizing what might occur. at the end of the world in Hobart. This is the city here, and we've got a bunch of PCG fires just plopping up around the place. What's interesting about Unreal Engine is that it's becoming more and more a kind of simulation environment, not just a gaming environment. And so one can really procedurally draw in world models and data about the world, satellite data and various other things, and then have procedurally generated elements which are intelligently or programmatically responsive to the data types that you might be interested in visualizing or working with. Now, the more interesting or relevant to this talk thing that's emerged is Unreal Engine 5.4, which is now in an alpha release. And that finally has really released, or is beginning to develop much. It's somewhat behind Unity, unfortunately, but they're doing it. A whole series of plugins or interfaces for AI, programmatic AI sort of APIs. And particularly of interest here is that they've got this machine learning adapter so that we can start working with ONNX models, which is the Open Neural Network Exchange models, and using NNEF format files and so on. So it looks to me that, I'm just beginning to look at this now, that this is an emergence of interface where one can start using Unreal Engine for in a simulation context with agents that might occupy an environment and learn about the environment and learn to interact with the environment. And so that's pretty compelling and interesting. And similarly, because I'm interested in working with Antarctic stuff and the cultural history of Antarctica, and visualizing that, it's a lot of, Antarctic data is visualized in a GIS system or software, and principally I've been using QGIS, and there's a wonderful data set which is worth downloading and having a look at from the Norwegian Polar Institute called Quantarctica. I didn't put a link in there, but if you just Google for Quantarctica, it's about, I don't know, maybe it's like a 20 gigabyte download. So it's quite a large project file. And it's got dozens and dozens of layers of correctly geolocated information in it, all sorts of shape files and shape layers and Lima Landsat data, and all the, you can see the different wavelengths or bandwidth bands that they're displaying there. The MODIS mosaic, it's got a digital elevation map, all this kind of stuff. So a whole extremely useful body of data regarding Antarctica, and it's super high resolution, so you can zoom right in to get really good detail of certain regions of the continent. And the great thing about QGIS is that it also supports interfacing with ONNX neural network file formats, and so one can start looking at things like segmentation, detection, and regression on these raster orthophotos in things like Quantarctica. And so I can see some kind of emergent pipeline there between this and cesium in Unreal Engine, and having a way of talking to neural network models and interfacing with them. So there's a kind of glue in between. Another important emergent thing with regard to this is satellite image deep learning. There's a whole lot of research going on in satellite image deep learning. And this is a really great website to go to if you're interested in that sort of area. I think it's important to, it's a very important thing for dealing with satellite imagery and geolocated data, that there are now really powerful tools emerging, a lot of stuff on Hugging Face and so on, for working with GIS data sets that can be queried in new and interesting ways. So it's well worth knowing about this. Now I'm going to talk about generative AI and deep learning in some more detail. When I started off working with AI stuff, I was going through a lot of GitHub repositories and downloading things and compiling things and so on. And of course, the torrent of projects that you come across on GitHub is just immense. I mean, it's far too much for one person to really absorb, and you end up, chewing up massive amounts of disk space and so on, and time compiling and getting things working and making sure that you've got all your dependencies sorted out, all this sort of stuff. And then happily in the last year, there's been this emergence of AI browsers, really, or kind of AI browsers. They're sort of really virtual environments that enable one to easily download and install and evaluate certain types of models. What do these things do? What are they useful for? What can I make with them? If you're not doing your own unique research or making your own models. And so I found Pinocchio to be super useful, particularly working with voice cloning and running Comfy UI and Duster, which are all packages which are, I think, going to be pretty useful for me going forward. And of course, Stable Diffusion, all this sort of stuff. And this is just, and it's essentially a, click and install. It'll create a virtual environment for you, download all the dependencies. I think I've got an example in the next slide of, oh no, it's in the previous one. But anyway, it'll fix that all up for you. And then you can start playing around. And this has been great for installing things like Comfy UI, which is a bit like, it's different to the stable diffusion. Is it the A1111 or something interface? This is that's a very commonly used interface, and this is a much more controllable but much more complicated way of using a node-based programming structure, again, to develop workflows for generative AI, specifically for working with things like stable diffusion models and generating imagery, and also working with things like LoRa's, which can be trained on custom data sets, so you can generate specific types of images that you might be interested in from your own small data set. The other tool that is great that I've been using is Visions of Chaos. This is an Australian guy who's put this extraordinary collection of everything you can imagine, really, agent-based modeling, cellular automata, and all sorts of things going on, reaction diffusion, visualization. It's a real sort of magpie collection of interesting visualization software. But it's, again, particularly useful for installing a whole lot of machine learning packages. For instance, things like Gaussian splatting and NeRFs, all this sort of stuff that you could go to, of course, GitHub, to the original repositories and download all this stuff and install it, or you can get someone else to do it for you and run it much more simply. And this is for running it on Windows specifically, rather than Linux. So I found this to be super useful. And it'll go through the usual thing of creating a virtual environment, connect a Hugging Face, it'll download the models and so on, and just basically it automates the whole process. And then you can run your Gradio application through your web browser interface from here. And then the last thing that I'll talk about, I think, from these sort of tool set things, which has been interesting for me, it's just been released very recently. There's a whole bunch of GitHub examples of things like Baby AGI and GPT for all and so on. Ways, sorry, these are reminder alarms to go and pick up my daughter, which are playing, but that's not happening. There are lots of ways of running local LLM models, which you can use for programmatically for assistance in programming, which is what I would typically use it for, because I can ask lots of questions and get programming problems solved really quickly about things which I don't know about or I don't understand properly. But again, there's a lot of management of the dependencies and installs and things like that. And what's interesting about Chat with RTX, which has come out recently from NVIDIA, is that it enables you to install a local model, such as the Llama 2 model here, which has got 13 billion int 4 parameters. So it's a pretty sophisticated model. And presumably in the future you'll be able to install a whole bunch of other ones. There's a separate $7 billion model with this, but I found the Llama 2 one to be pretty effective. And what's useful or striking about it is that it's set up to allow you to query a database of which just a folder of some sort in which you put a bunch of data. And I've got here my AAE folder, which is the Australasian Antarctic Expedition folder, in which I've put it in a whole bunch of scanned PDFs of the scientific records produced by the Australasian Antarctic Expedition of 1911 to 14. And I was interested to see how this would work with RAG, or Retrieval Augmented Generation. So I've asked it the question here, describe the contents of the PDF, and it's given me a not terribly accurate description of it, but serviceable and so on. So it's the beginning for me of the idea that one can consolidate bodies of different types of data, not just image data, but specifically textual data here. That would be the kind of things that you would find in, for instance, museum archives or library archives or whatever, that can then become queryable by a locally running LLM model of some sort. And so that's a pretty interesting sort of prospect there, because of course these, if you look at these, say, the scientific publications of the AAE, it runs to thousands of pages, far too much for somebody like me to read. But I suddenly have the capacity to have a locally intelligent LLM, or what would I describe it as? Not really a collaborator, but a sort of a technology, a large language model that I can use to then make a set of queries about that data resource, and then look at some cross-matching of the data with other things I might be looking at, assuming that it doesn't confabulate or hallucinate too much, which is a big problem, which we'll talk about, but it's just early days for this kind of stuff. The other thing, one last thing I was going to mention, was looking at, of course, at AI movies. You're probably familiar with Pika and with Runway ML and so on, and this is the stable diffusion animate diff prompt travel that one can use to generate a whole lot of amazing AI movies. So now I'll run through some examples of things that you've got an idea of what I'm talking about. This is the first work that I started doing with NERFs early last year. And what's happening here, this is a building called the Transit Hut, which was used to make astronomical observations in Cape Denison in Antarctica as part of the Australasian Antarctic expedition. And you can basically, running through a sort of training sort of process here and refining the NERF. This is instant NGP when that first came out. And it was pretty exciting to get that running and enabling me to run that upon these photographs that I took quite a few years ago now. And what was revealing to me about that was the ability to revisit one's own archives of places that you would have been to, where I may have taken photographs for photogrammetric reasons or doing panoramas and so on, but now I can turn them into much more interactive 3D types of models using NERFs and Gaussian splats. So that's the first example there. Other things which have been super exciting for me is to go back through helicopter footage that I shot.
Can you turn off the audio? We can't really hear you speaking over the video.
Oh, okay, sure. Yeah.
There we
If I can figure out how to do that. Um, I am screen sharing more. But it's good to know that you're getting the audio from the movies anyway. So I'll just go through this again. So this is raw helicopter footage shot in 2009 in Antarctica, Cape Denison, and then I've pumped out the frames there, converted this into a Gaussian splat, and then this little movie is rendered. I think it's through I forgot the name of it now. There's a Gaussian splat viewer, which is a Gradio app basically, and then you can just put in a camera path and fly through and virtually revisit a scene. So we can see the splatting sort of data up here. And these tools are really improving a lot now. So a lot of the floaters are getting one can get rid of these and so on. And it's becomes a very compelling way of creating a fully immersive, fully 3D interactive version of what was 2D shaky helicopter footage from more than from 15 years ago. So that's absolutely fantastic for me, because it means I can revisit all my archives of this material and investigate it in new and interesting ways. Similarly, I undertook a bit of what I think of as YouTube archaeology. I'll play this. And this is a example neural radiance field based upon the underwater submarine, remotely operated submarine that discovered the Endurance, or that went down when the Endurance was discovered recently. This is just a series of frames pumped out using FFmpeg, about 180 images, I think, and brought into instant nerf. So we can see that there's quite a lot of noise, obviously from submarine data, water and so on. So I'm just doing some tests at the moment to see if I can clean up the radiance field. I'll just pause that there. If you look at the source video footage, this is taken from there was publicly released data from the Endurance, I think it was Endurance 2020 expedition. I can't quite recall, 2022 expedition, or 2021 maybe. It was video footage, and there was a lot of because it's underwater, there was a lot of floating material in deep. This is really at the bottom of the ocean off the coast of Antarctica. So an incredible discovery by Menson Band and team. They went out there, an amazing expedition. And one could download this video footage, and it struck me, of course, this is a great opportunity to look at doing neural radiance field reconstruction so that one could virtually visit this place, because this is a classic instance of why this sort of technological approach is useful, because it's so hard to get there, almost impossible to get to places like this. And so if one can reconstruct or create 3D images from video footage, then you can virtually revisit them and analyze them in much more detail over time. And it was, I think there are other, I did a lot of looking into how one can specifically process underwater imagery to remove things like, diffraction and, suspended particles and various issues like that. And there are some deep learning approaches. There are some physically based approaches as well, which are quite striking, and they aid in the retrieval of color from underwater imagery as well, because there's a whole lot of optical constraints that occur underwater that make it quite difficult to do this sort of stuff. And so it was, but nevertheless, it was very striking that one could then generate these sorts of models and do interesting things with them. So I did, going from that, moved on to, from the neural radiance field approach, to looking at Gaussian splatting. And Gaussian splatting is a much, to me, I mean, visually, it was much sharper. and also much, much quicker and much less sort of compute intensive. So the attractive thing about generating Gaussian splats and things like the endurance and stuff and various other models I've been working on is that they're much more lightweight, they're easier to work with, though I think both have, drawbacks and benefits. But also they're supported now in Unreal Engine, which is great. So I did some other, I don't think I have the movie in this slideshow, this presentation, but I took this endurance model, stuck it in a Unreal Engine world at the bottom of the ocean and put fish swimming around and all this kind of stuff. So one can do these sorts of reconstructions of the remote environment as well. Now this ties in with earlier work that I was doing on virtual South Georgia, because of course that was Ernest Shackleton's ship that you just saw that sank to the bottom of the ocean, and they were stranded in the Weddell Sea. They were stranded on sea ice for about 6 months, and then got off to Elephant Island, and then Shackleton did this extraordinary ocean voyage in a ship called the James Cairn, or not a ship, a little rowing boat basically, or a skiff, and sailed something like some extraordinary distance, 5,000 kilometers across the wildest ocean on Earth, to the island of South Georgia, eventually making his way across the internal landscape of South Georgia, which had never been crossed by anyone. This is Shackleton's voice.
In great advantage to science, and for the first time returning without the loss of a single human life. And throughout all this, I was helped by a party of men who were regardless of themselves and only thinking on good of the expedition. I, Ernest Shackleton, have today, March the 30th, dictated this record.
So what I'm interested in here then is that one could tell an extraordinary story about Shackleton and the endurance and the landscape. We've got his voice, we've got all the terrain information about obviously South Georgia, and because it sees him in Unreal Engine, one can go to Elephant Island and go to the Weddell Sea and run simulations of the breakup of the ice and the ship, and we've got the underwater footage of the ship. All these sorts of things can come together in I think a big project to do. That's something I to over a period of time, aided specifically with these sorts of AI tools as well. Because the other benefit of the AI tool is that for a person like me who typically works on their own, I'm unfunded, I have a lot of stuff I just do off my own back, it increases my productivity quite significantly, and enables me to do things that I would not otherwise be able to do. The other thing that I've done with this virtual South Georgia is render this out in stereoscopic 360-degree video. So you can pop it on a headset and go on the flight around the island. And I think that's an interesting platform to explore with things like the Apple Vision Pro. So I've got lots of other videos to go through. Because I'm talking about natural history as well, quote unquote, or brackets, I'm interested in how we can look at the animal life as well.
Down the base of vertiginous slopes, the remote hut at Herd Point perches above a rocky headland and small bay.
So this is, oops, this is Virtual Macquarie Island, which was a project I completed last year.
Down the base of vertiginous slopes, the remote hut at Herd Point,
and this is a sort of 30-kilometre long island, 1,500 kilometres off the coast of halfway between Tasmania and Antarctica, and it's where the 1911 to 14 Australasian Antarctic expedition set up the base. There was a lot of whaling that occurred on this island since the 19th century, and now it's a national park, and it's
where
historically and
researchers can
environmentally
spend
a
weeks
very,
at
very
a time.
significant place, and
Royal
almost
penguins,
impossible to get to.
southern
Well,
elephant
you can
seals,
go there on
giant
cruise
petrels and
ships,
fur seals
which are super
all gather
expensive,
in this
but
wild
principally
place.
it's an island
Some
of
are merely
scientific
metres
research,
away from the hut,
and there's a whole lot
but
of
there is
interesting
more.
stuff going on, and these amazing colonies of penguins and seals, and there are millions of them. And the question was, how can we show, here we've got 100,000 penguins running in real time in Unreal Engine 5.5, one I think it is.
The largest royal penguin colony on the island is a short walk away. Hundreds of thousands of penguins squawking, fighting, calling. It is overwhelming.
This is working with my colleague Gina Moore, who's from the Royal Melbourne Institute of Technology. She's an absolute expert in animation. And these are VATs, vertex animated textures. So they've got a very low GPU overhead. So we can run hundreds of thousands of these animated individuals across the landscape. And you can do interesting things like attach behaviors to them and animation routines and so on. And in the future, when the AI stuff becomes more tractable, I imagine that we'll be able to turn these into agents, which is really interesting, or you know, a kind of AI agent of some sort that will move across the landscape and they could exhibit behaviors. So that's virtual Macquarie Island. So the interesting thing there, then, and we get into virtual observation of these creatures. What will they be doing? Of course, they're doing what I've told them to at the moment. There's no reason that it needs to be like that. They can programmatically show some sort of independence. They can interface with machine learning models, then they can learn about their environment, they can have objectives, goals, they can go and do things, they can life cycle, all sorts of interesting things can go on. And also, you could drive their movement and their the whole life cycle by connecting it with observations of satellite data as well. You can see these colonies from space and them with hyperspectral data and how they move around a landscape and various things like that. So this was me sort of simulating kind of David Attenborough wildlife documentary shot at wildlife. Now, there's animals, of course, and there are human animals as well. This was an earlier work that I did. I was interested in looking at how I can bring to life 100-year-old glass plate photographs of the expeditioners who were on the 1911 to 14 Australasian Antarctic expedition. And this was using a few routines I sort of figured out myself, and also some online services that could do face animation and so on. This is old now, and it's become much more malleable and complicated, the sorts of things that one can do to these old photographs. So I can now be in the position to turn them into genuine 3D models and faces, and be able to navigate around them and animate them and so on, and in color, and prospectively situate them in the landscapes where they were working, which is kind of interesting. And the other thing is, if you think about it, if they're to interface with something like RAG, like retrieval augmented generation, all of these people kept diaries as well. So it will be feasible to create avatars of them, which are driven by the RAG queries that one would have about their diaries that they were, writing at the time that they were on this expedition. So there's a whole interesting possibility of re-invoking these figures from the past and having them, they won't be played by actors. If there were recordings of them, you could actually do voice synthesis and get them to speak in their own voices, for instance, and read their own diaries. And that's kind of an interesting sort of prospect as well. So how am I doing for time? Okay, doing okay. And then I became interested then in voice synthesis and stuff, and so this is a slightly whimsical and funny sort of project that I'm working on with a friend of mine, Glenn. We called it Planet Plop, and
let's tiptoe through the stars to a world beyond the Mars. The sky is a rainbow swirl.
basically generating human-like figures and synthetic voice. We just did this kind of silly musical sort of thing. This is just a way of getting this stuff working and seeing what we can do.
Plop in the cosmic sea, a world of wonder and mystery, with alien creatures. So much to see. And come with me to Planet Plop.
Okay, so I'll leave that there. Planet Plop, that's more a kind of humorous learning thing.
Let's tiptoe through.
We'll go through. So the point that this brings me to is what I think of as the introspective archive. Okay, that everything is a vector. This is the compelling sort of insight from all this work with machine learning and so on. And that basically, if you look at the emergence of things like multimodal LLMs, such as we've got, text-based models, we've got vision-based models, we've got text vision models, which can do cross-matching across this and so on. We've got things like RAG, retrieval, augmented generation, COT, chain of thought reasoning, and there's a whole various other sort of graph models of reasoning processes that these LLMs can undertake. And all the data that you have, that basically everything that is digitalized can be vectorized. So every single thing that you have a scan of, or you have your PDFs, anything on your computer essentially, that photographs and text and audio and et cetera, can be turned into a vector. And then because it can be vectorized, it can be tokenized as well and stored in things like Pinecone, vector databases, all this sort of stuff. So you have this very powerful sense of being able to query these different, what would normally have been seen as different types of data, fundamentally separate sort of types of data. When they become vectors, they become, I guess, the same sort of thing. And one can make sort of cross matches between them. Exactly how you do that, I'm not quite sure yet, but that's my feeling about it, that everything can become a vector and everything can be in a database and it can all be queried in interesting sort of ways. But there are lots of emergent issues about that. What are the different multimodal tokens that one needs to start thinking about? What's the sort of semiotics of this? How do you mitigate things like hallucination and confabulation in your machine learning models, looking at a database of that sort? And also, what are the ethics of this kind of thing, particularly if you're looking at indigenous heritage in museums or whatever? There needs to be some sort of parameterization or sense of the sort of ethical control around that as well, because of course once you've trained models upon creating certain types of images, you can endlessly create them, and it devalues, I guess, the original image. Or how do we determine what what is human made and what's machine made and so on? How do you indicate that? All these sorts of issues arise as well, and so my thought about this now is that we have the archive. We have LLMs, typically mixture of expert LLMs. You'll be surrounding this with mixture of expert agents, which will have different ways of querying your archive through the LLM model, whatever that particular model is. And then surrounding that are human agents and curators who are going to be asking questions. It's because the thing to remember, I guess, about agents and LLMs and stuff like that is they don't have intention. It's still human in the loop kind of stuff, because we need to form the intention to get them to do things on our behalf, to query the data. And that's where my thinking is at the moment. Thanks.
Questions? If you stop sharing your screen, Peter.
I will. Okay. Stop share.
Hello?
Ah, there we go. Hello, can you see me?
Yes, can you see us?
Yes, I can see you all. Oh, you're there. Oh,
Hi. How's WA?
good. Warmer than Tasmania. So I can actually go swimming in the sea without a wetsuit, which is great.
Very good. Well, it snowed here this morning,
Oh, God. Okay.
spring.
Well, you could go skiing, which would be
Yeah.
fun.
So your point at the end was super interesting because, you know, we have this framework in the laboratory called computational museology, which connects machine intelligence to data curation, ontology to visualization, and communities of publics and practitioners to immersive visualization of that world of knowledge. Yeah. So
Yeah.
it's exactly what you said. I think we are in parallel there.
Oh, good. Okay, well, that's good to know. I'm not alone.
You're not alone. Are there any questions? Yes.
Yeah, thank you so much for that.
Can you hear? Just let us know if you can't hear.
Yeah, sure. Yeah, I'll try my best.
Yeah.
Thank you for the wonderful talk. I just had a question about your chat with RTX, the LLAMA project. Just in terms of the kind of historical sources that you put in via PDFs. I think we're trying to do something similar where we're going to try to consolidate a bunch of historical sources that we could then query. And
Yeah.
possibly we can put in some multi-modal elements. So yeah, I don't know if you could just sort of maybe just talk about that a little bit more, or just yeah.
Yeah, okay.
Oh, actually, it's easier maybe.
Yeah, so well, I'm happy to talk about that. So that was that's very early days for me to do. What's happening? Oh, camera's moving around.
She's walking to the screen, so you can actually see her at a certain point. There we go.
Oh, okay. Hello.
Hi.
Yeah, so it's very early days for me with that, with the chat with RTX kind of thing. And it was really just a test to see what sort of data can I get it to work with. Initially, I started using it for doing tax returns and seeing if it could read bank statements, which it wasn't very good at, and it couldn't do maths. So that was kind of interesting. But that ability will improve with more sophisticated models, obviously, and so on. What was appealing about the chat with RTX thing is the RAG, essentially, that you can basically direct it to a specific directory that you have, and you put a bunch of information in there. What's interesting to me is that I put the AAE PDFs, these are scanned PDFs of 100-year-old published books. And there's a lot of noise in parts of the scans. And the OCR on it has not worked terribly well. So what I'm interested in doing is setting up a pipeline using Tesseract, where one would programmatically run PDFs or scans or whatever your source materials are through Tesseract, which is a Google open source OCR library. And that means you can basically automate the production of your OCR sort of stuff, which is great. So you can just have a folder, put whatever material you want into it, run Tesseract over it, which are LSTM trained models, and they'll then generate. It will either embed. You can get it to embed the text in the PDF as a PDFA or whatever, or you can just get it to spit out the text as it is. But of course, with OCR, it's still it's getting better, but there's still things which will be misrecognized. So once that's done, then you have a RAG source of some sort, which is going to be useful. What was interesting to me was you've got to think about the types of prompts. Again, it's going to come down to a sort of prompt engineering sort of thing. What are the questions that I'm going to ask? If I've got 1,000 pages of scientific documentation about something, I need to be able to ask the LLM very specific questions about it. because it's quite stupid, really. It doesn't think like a human at all. And so I was asking it to describe what was in the PDFs, and initially it just spat out a whole lot of gobbledygook. Until I started asking specific directive sorts of questions, or questions which have a kind of chain of thought reasoning, or say, you are an expert in reading this kind of thing. You are very good at this, or you are thinking analytically about this, or whatever. Or do this step by step and then explain what you're doing. And that typically seems to be something that's procedurally important for large language models to go through. So that's just my sort of feeling, my hunch about that at the moment. But it's early days, and I'll take it from there. Does that sort of help with your question at all?
Yeah, it does. Thank you.
Okay, thank you.
Great. Other questions?
I have a question.
Yep.
Maybe go up to the camera. It's so much better.
Is this kind of like a robotic camera or something that pans around?
Exactly. Normally it zooms in on people's faces, but it's not doing
All right. Is this kind of panning around for me?
Yeah.
Like this? Yeah.
So my question is, for those of us doing research in this field, we feel like we're on the edge of something, right? That AI is going to transform how we engage with materials, and also like open up possibilities for new types of visualizations. You talked about this a little bit, but I was just wondering if you have any kind of dreams about what you'd like to do with AI that you think is coming, some really cool things in the future. I just wanted to hear more about that.
Yeah, sure. Well, it's not, well, okay. I've got a bunch of weird sort of arty projects that I'm working on. I often use sort of artistic projects as an experimental platform, because it means that I'm not constrained to having a specific research outcome. Okay. So at the moment, I'm working with a colleague of mine, and we're looking at how we can bring together a whole lot of plate tectonic data to do with the evolution of life on Earth. This is a totally separate project, nothing to do with this Antarctic stuff at the moment. And I've always been interested in space science and astronomy and all this kind of stuff and so on. And but with a background in geophysics, there are wonderful bits of software which enable you to simulate the history of plate tectonic movements around the surface of the Earth. So you get the breakup of the various continents like Rodinia and Pangaea and all these sorts of things. And then, so this is work where I would like to be able to, with something like RAG, what would be super useful for retrieval augmented generation or having an agent would be to have some sort of agent that could synthesize a whole lot of information for me from different areas about the origins of life on Earth. Okay, because there's literally hundreds of thousands, or probably millions of PDFs and things on arXiv, or whatever you call it, archive, that cover these sorts of areas, and it's impossible to develop any kind of authoritative knowledge in an area these days. It's very hard to be a generalist. I'm kind of a generalist, but it's becoming harder and harder to be a generalist. So I think that you need these sorts of agentive kind of tools to be able to synthesize this information for you. But the problem is the hallucination problem. And so that's why RAG is super, super important, and things which are analogous to RAG are super important. So my dream of this sort of stuff is that I would like some way of verifying what's said by these things. How can I assign a truth score to something? How do I cross-match it with the data source? Maybe there's a way of doing that through some sort of vector analysis or whatever, through a vector database. Is it because I guess there are interesting things in vector databases that you can have information represented as a series of points, like a classic is the TSNE visualization and so on. But there are some interesting things I've seen done where you can plot, you have your t-SNE plot or whatever, but you can abstractly move between points in a plot and move through things which don't really exist. Okay, and these are I think these hallucination points and so on. So is there a way of weighting this or determining, what are the observed truth values and then what are the hallucinated sort of objects and so on? So some kind of way of verifying the truthfulness of something would be super helpful. And then I would like then to use that to be able to analyze the content of scientific papers, and then use some of that to drive things like visualization of the early history of the Earth or the origin of life, or this kind of thing as a visualization thing. But so I guess the question is a kind of an ontology of provenance. You want to be able to move from one point to another point to another point, and be able to have that scientifically verified, and such that it's credible, as opposed to just being a weird sort of arty fantasy thing. But I'll start off with the weird arty fantasy stuff, and then use that as a model of what one might want to do for a scientific approach to this. Yeah. So if that answers your question.
Yeah, absolutely. Yeah.
Okay. Well, thank you.
Any more? Okay. No, you can also contact Peter on email.
Okay, great, thank you. Yeah, so basically just in your work with stereoscopic images, what do you like most about them? And when you think about augmenting them, like what kind of questions or what kind of approaches do you take?
Yeah, sure. That's a good question. I mean, I've liked them ever since I was a kid, because I grew up with one of those ViewMasters. If you know the ViewMaster thing, you put the little slides in and stuff like that. So I like them, nostalgically like that. The way I came across the stereoscopic stuff early on it was amazing to me, because I was on a aeroplane. I used to live in Berlin in Germany, and I was flying back to Perth, because I mean not to Perth, to Melbourne. I had a job at Melbourne University, and I was on the plane and I read a book by a historian from Monash University called Philip Ayres, and it was about it was the biography of Douglas Mawson, who was the leader of the Australasian Antarctic expedition. And in the book, it had a reproduction of one of the glass plates from the expedition, and it said half of a stereoscopic pair. And that was like, huh? They took a stereoscopic camera with them in 1911 down to Antarctica. Kind of crazy idea. I had no idea that they did things like that. And then that got me on the whole stereoscopic sort of history of stereoscopy sort of stuff. And I ended up phoning up Philip Ayres, and he said that he had got access to this collection called the Morse collection at the Museum of South Australia. I contacted them and then found that there were dozens and dozens of these stereoscopic glass plates taken by Frank Hurley in Antarctica in 1911, which to me was an absolute revelation. And since then, I've discovered, of course, that there are literally tens of thousands of these things in museums around the world. In America, I think there's one museum that specifically collects stereoscopic photographs. So that, to me, is an absolute gold mine, because these days you can use AI tools to do image or 3D modeling from single monoscopic images. It'll use a neural network or whatever to generate a depth map. But the benefit of having a stereoscopic pair is that you actually have genuine depth information in that picture as well. So presumably, if you to use that with something like Duster, for example, that will work. That will generate super fast Duster, quite amazing. Almost instant. It will generate a point cloud for you of a scene from a stereoscopic pair. So I would like to go back to Hurley's stereoscopic photographs and the environmental modeling that one could do of the context that they were taken in, and create a sort of time machine where you could fly back to the world as it was then and go to the points where he took those photographs from. So and I think that is coming within the realm of possibility to do that in a convincing sort of way. Yeah, so that's my interest.
Thank you.
You're back.
Fantastic. I'm back. We're doing this big project on the Universal Exhibition in Paris of 1867 with about 1,000 stereo pairs. Yeah.
Right, that's the one that Paul was doing colorization for? Is that correct?
It's
yeah.
Yep. So
Yeah.
that's boring along. But in this process, we've been meeting all the stereo photography geeks of the world, right?
Right.
So I just met this guy in Martin Kohler from Germany. And he did a big exhibition on the stereo slides of Zeppelin air machines.
Oh,
Yes.
wow.
Oh,
How
wow.
fantastic.
So,
Yeah.
yeah, fantastic. So I'm going to try and talk him into doing a big visualization of that, because that would be so gorgeous, right?
Yeah. Well, if you need somebody to do Unreal Engine modeling of Zeppelins,
Yes.
keep me in mind. I would love to do that.
Okay, cool. Yeah, great. Any more questions? No questions. Thank you
Oh,
very
well,
much.
everyone must be overwhelmed then. That's a good sign.
Yeah, like in the headlights of the oncoming train. Yep.
Right. Okay.
Thank you, and we will chat anon.
Yes. Okay. Thank you very much. Really nice to see you again. And good luck, everybody. Hope your projects. I'll look forward to finding out about your projects and research one day as well. That would be fantastic. But good luck with it all. Okay.
Yeah.
Thank you very
Okay.
much.
See you then. Okay. Bye-bye.
Ciao, ciao. All right, everyone. Take about 10 to 15 minutes break, and we'll be back to start on the workshop.
Apologies, but the croissants are now in the kitchen.
They what?